Hi there, this is Ms. Page. In this lesson, we are continuing our learning about how to graph sine and cosine functions using amplitude, period, and midline. In the first part of this lesson, we introduced the concepts of amplitude, period, and midline, and now we're going to apply them to graphing sine and cosine functions. So we want to talk a little bit first about how amplitude, period, and midline connect to our learning of transformations that we have used with other functions. So when the period changed to something other than 2 pi, that represents when we have a horizontal stretch or a horizontal compression. When the amplitude changes to something other than 1, then that means we have a vertical stretch or compression. And if we have a vertical translation, that is a change in our midline. So our midline, which is the x-axis in the parent functions at y equals 0, moves up or down according to a vertical translation. So we can also, and we'll see some in these examples, have reflections across the x-axis and the y-axis. When we have these, they do not change the period, amplitude, or the equation of the midline. So we don't see changes in those three characteristics if there's a reflection. The one thing I didn't mention here is a horizontal translation, shifting left or right. That in trigonometry is what we call a phase shift, and we are going to talk about that in a future lesson. All right, so when there are multiple strategies for graphing sine and cosine functions. The one that I am going to be sharing with you here relies on our understanding of our unit circle and our quadrantal angles and either sine values of those quadrantal angles or cosine values, depending on if we're graphing sine or cosine. So if we're going to graph a sine function, then the quadrantal angles actually represent all of the maximums, the relative maximum, the relative minimum, and the three intercepts when we're looking at our first revolution from 0 to 2 pi. So 0, 0, this would be 0 radians, and this would be a sine value of 0. This is our pi over 2 radians with a sine value of 1. This is our pi radians with a sine value of 0. This is our 3 pi halves radians with a sine value of -1, and then 2 pi radians with a sine value of 0. And that gives us these points here, 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 and here. And then drawing a smooth curve through those points connects them to give us our first cycle, or one full period, of the sine function. So we're going to use those key points to help us graph a sine function quickly and easily. For cosine, because we'll be graphing both of them in this particular lesson, we are doing the same thing. We're going to use those quadrantal angles. When we're dealing with cosine, at 0 radians, the cosine value is 1. Pi halves radians, our cosine is 0. Pi radians, cosine is -1. 3 pi halves radians, cosine is 0. 2 pi radians, cosine is 1. 1 is the maximum value for cosine, as it is for sine, and -1 is the minimum value for both sine and cosine. The difference is where they start. So cosine starts at 0 radians with a value of 1. So it starts at a relative maximum, then goes to an intercept, then goes to a minimum, then back to its midline, and ends at another relative maximum. Whereas our sine function starts at a midline point, which here is also an intercept on the x-axis, then goes to a maximum, intercept or midline point, minimum, and ends back on its midline. So they start at different places. So you have to make sure that you are starting in the correct place for a sine function. You start in the midline, versus a cosine function, you would start at a relative maximum. All right, so this goes over parameters like we've dealt with. In our sine and cosine functions, you'll see that we have both parameters of a and 1 over b. Our a is what creates our vertical stretches and compressions, and we can also have an x-axis reflection there. Our 1 over b is what creates our horizontal compressions, horizontal stretches. We can also have a y-axis reflection there. And then our k, we're also dealing with that. That is what affects our midline and gives us a midline of y equals k. All right, so another strategy, something else I want to point out to you is when I'm trying to, if I have to figure out what scale I want to use for an x-axis, a good scale to try is pi-4 radians, so have every square or unit be represented by representing pi-4 radians. But if that scale won't work nicely, then another strategy you can try is to divide the period of the function by 4 and see what that gives you. And that often can be a good one. You can also just kind of keep cutting that in half too if you want to spread things out a little bit more. So the strategy that we're going to be using is to figure out the points at the beginning and end of the first full period or cycle of the function. Then we will fill the points in between those two. We'll fill in the other key points, whatever they might be, given we have sine or cosine. And then, if necessary, we will extend our graph using the same pattern as far as necessary to the left and the right, drawing a smooth curve then to connect all of those key points together. All right, so let me show you what that's going to look like here. So in this first example, we are to identify clearly the period, amplitude, and midline, and then we'll use that information to graph. So even if we weren't asked for period, amplitude, and midline, we would still want to know what they are in order to make sure that we could graph using the strategy and also to make sure everything looks right. So the period of the function, what we actually do is we take our 2 pi radians, which is the period for sine and cosine parent functions, and we divide it by our 1 over b parameter, which is the coefficient of x. In this case, we've got a 1 right there. That's 1x. And so we would be taking 2 pi, we would be dividing by 1, which means our period is still going to be 2 pi radians. For the amplitude, we would take the absolute value of our a. So the absolute value of -1/2, which would be 1/2. And that means from our midline to a maximum will be a 1/2 a unit, and from our midline to a minimum will be 1/2 a unit. And then our midline is y equals k, and k in this case is 0, because we don't have any factor added or subtracted from our sine function there. So we get y equals 0, which is our x-axis. Now I am going to, here we're given a graph with scales already on it, so we'll just use this. I'm going to go ahead and graph a dashed line at my midline. If your midline is your x-axis, you don't really need to do that. In fact, you don't have to graph the midline if you don't want to, but it can be a really good tool for being able to graph all the other points quickly and easily, and to make sure your graph looks right when you're all done. So this is my midline, y equals 0, or my x-axis. All right, so now what I'm going to do is focus on sine. So my sine function for 0 radians, at 0 radians, sine is 0. So that means that my first point is going to be right there at 0, 0. The period of my function is 2 pi radians, which means that 2 pi radians beyond this point right here, it's going to be back in that same location. So it's on its midline right there. Now what we have to understand about the sine function is that exactly halfway between these two midline points is another midline point. Then we have to realize that halfway between these first two midline points is a relative maximum. That's your pi halves, comma, 1. This value is what's going to be affected by your A parameter. So we call that the absolute value of that our amplitude, but you can also just look at it as, okay, well that means that this value right here, which would have been at 1, is going to be compressed by a factor of a half, and then it's going to reflect across the x-axis because of the negative value there, and it's going to end up right there. Halfway between the second two midline points here should be a relative minimum in the parent function. That is your 3 pi halves, comma, negative 1 for sine. And that negative 1 then is affected by your A parameter in the same way the previous point was. So it's going to reflect and move up to positive 1 and compress by a factor of a half to right there. Then we should extend the graph of the function using the same pattern. So this is our first piece. Let me make my line a little bit narrower. So this is our first piece. So we've got now, it's going to go to, from here, it's going to drop down because we're repeating this first piece right here, which gives us another relative minimum, goes back to its midline, then goes to a maximum, goes to the midline. So this piece does that. Then it backs up over here. So from this, it has to go up to a maximum, midline, minimum, midline, maximum, midline, minimum, midline. And so it backs its way up. And notice the nice smooth curve. It's called a periodic curve, where it's constantly waving through the same curve or same piece of the curve. And that does it. That's our sine curve for this one. All right, let's take a look at this one. All right, so here we are graphing g of x equals 4 cosine of x. So the period would be our 2 pi divided by our coefficient of x, which is 1. So again, our period is 2 pi radians. Our amplitude is the absolute value of 4, which would be 4. And then our midline is y equals k, which would be y equals 0. So our midline again is our x-axis. So I'm just going to draw in a dashed line there to make it clear. That's what I have. Okay, so now I'm going to start graphing cosine, and I have to remember where cosine starts. So for cosine of 0 radians is 1. So that means it starts right there. Our period is 2 pi radians, which means 2 pi radians later, it is back at that same type of point. So it's back at a relative maximum. That's a relative maximum. Begins and ends. Now for cosine, we have to realize halfway between these two relative maximums is a relative minimum, and that would be here. Then halfway between a relative maximum and a minimum for cosine is a midline point, which would be here, and halfway between relative maximum and minimum would be a midline point there. So this is our first cycle for cosine. Then we want to extend that to cover both ends of the graph. So from a maximum, it goes to its midline, then to a minimum, back to its midline, back to a maximum, drawing a nice smooth rounded curve, little hills and valleys. Watch your end behavior right here. Remember, that's a maximum, so it's turning around and heading down right there. Backing it up from a maximum, it goes to its midline, to a minimum, to a midline, maximum, midline point, minimum, midline, maximum. And then draw your curve. And again, that's a maximum, so it turns around and heads down. So watch your end behavior there also. And there it is. All right, we're going to try practice problem. Oh, never mind. We are going to do all the examples and then try our practice problems. Okay, so let's take a look at this one. So what I have added for this example is a k value other than 0. All right, so now our midline is going to move. So the first two examples, our midline stayed at the x-axis. Now it's going to be someplace else, but the other two things will do exactly the same way. So the period would be 2 pi divided by our coefficient of x, which is 1. So that's 2 pi radians. We will deal with changes in the period in the next lesson. Amplitude is the absolute value of -3/2, which would be +3/2. Midline is y equals k. K is +4. So we've got a midline of y equals 4. All right, so I am going to put a dashed line at my midline of y equals 4. So here's where my midline will be now. Now I'm going to figure out where does sine, or actually cosine, I'm doing a cosine function. So where does cosine start? So my unit circle tells me at 0 radians, my cosine value is 1. All right, here's what's going to happen here. So that would normally be right here. But we have a midline that's up here, which means that we've got several things going on. Transformation-wise, what's happening is that this 1 is going to be stretched by a factor of 1.5, and then it's going to reflect below your x-axis to -1.5, and then it's going to translate up 4 units, which is what a k value does, and that is a k. So it moves up 4 units, 1, 2, 3, 4, which puts it right here. So that becomes a relative minimum in this case because of the x-axis reflection. Now, another way of doing it is to actually use your midline as your new line of reflection. So you start 1 unit above, that's your 0, 1 position. So it's like you've already done the up 4. And then you reflect across your midline. So now instead of being 1 unit above your midline, you're 1 unit below your midline. And then you stretch that by your factor of 1.5. So it ends up right here, 1.5 units below your midline. It's another way to do it. Remember that, so 2 pi is our period. So 2 pi units later, we are going to be back at that same type of key point, which is a relative minimum. So there we go, we're right there. For cosine, halfway between two minimums would be a maximum. And our amplitude is 1.5. So that means that it will be 1.5 units above our midline, right there. Halfway between a maximum and a minimum is a midline point. So we have a midline point there. We have a midline point there. So this is the first cycle, 1 full period of this cosine curve. All right, so now we're going to extend it. So from going to the right, from this minimum, we hit our midline. Then we hit a relative maximum. Then we hit our midline. And we hit a relative minimum. So that curving. And again, this is a minimum, so make sure you watch your end behavior. It's coming back up after that. Going to the left, from this minimum, we go to midline. Then we go to maximum. Back to the midline. To a minimum. To the midline. To a maximum. To the midline, and we end in this case at a relative minimum. So curves waving through, coming back up after that minimum. Now, a good visual to make sure that you have done this correctly would be to make sure that this distance right here is the distance you're calling your amplitude. So we said our amplitude is 1.5 units, and that is 1.5 units from the midline to that maximum, 1.5 units from our midline to a minimum. And make sure that's the same for all minimums and maximums. All right, let's take a look at the final example here. There we go. All right, so now we are going to graph a sine curve with a k value other than 0. So the period here will be our 2 pi, which is our period of our parent functions, divided by our coefficient of x, which is 1. And that gives us 2 pi. Amplitude would be the absolute value of a, so that's the absolute value of 2, which is 2 units. And then our midline is y equals k. K here would be -3. So we get y equals -3. So here's where my midline will be. All right, so now I got to figure out where my function is starting. So I'm graphing sine. My unit circle tells me at 0 radians, sine is 0. So it would start right here. But my midline's down here. So that means that this point is going to move down to this midline. It's like a translation down 3 units, which again is what your k value does. Period is 2 pi. So 2 pi units after this, we would have to have another point of that type, which would be a midline point. Now remember, for sine, halfway between these two midline points is a third midline point. A lot of people make a mistake with that. That has to be a midline point for sine. Then halfway between these two midline points would be a relative maximum. That relative maximum is affected by our a parameter, which is +2. So there's no reflection, so it will stay a maximum, but it does stretch by a factor of 2. So instead of being 1 unit above our midline, it stretches to 2 units above the midline. And then halfway between these two midline points, we have a relative minimum that stretches to 2 units below the midline. So this is our first cycle for this sine curve. So extending it from this midline point, we would go to a maximum, then to midline, then to minimum, then to midline. That would complete this side. From the midline, remember, it's going up to its maximum. So your end behavior should keep going up a little bit, showing it's going towards its next maximum. Backing it up to the left, from midline, we were at a maximum here. So from this midline, we have to go to a minimum. And then midline, maximum, midline, minimum, midline, maximum, midline. And connecting those with a curve. Again, it would go down from here because this is a midline point, so it's heading to its next minimum. And that completes that sine curve. All right, let's try a practice now. Pause your video here, give this one a try. All right, let's take a look at the results. So the period is 2 pi divided by 1. Amplitude is the absolute value of 3, which is 3. Midline is y equals 0, k is 0. So we're graphing a sine curve. So it should have started on the midline, 2 pi units later, midline, halfway between those, midline. There's no x-axis reflection, so here's your maximum. It has a stretch with a factor of 3, so instead of being 1, it stretches to 3 units above the midline, and the minimum stretches to 3 units below, and then extending it to the left and the right. Let's try another one. Here you go. Pause your video. All right, let's take a look at this one. So here we've got a period of 2 pi divided by 1, coefficient of x, which is 2 pi. We're taking the absolute value of negative 5 halves, which would be positive 5 halves, or 2.5. And our midline would be y equals 1, our k value being 1. So here's the midline. It's not drawn in on this graph, but I do like to draw it in. There's your midline. So we're graphing a cosine function. We know that for cosine, our unit circle tells us at 0 radians, we have a value of cosine of 1. What's happening with this 1 this time is that it is being affected by your a parameter. So it's reflected to negative 1. Then it is stretched by a factor of 2.5. So it stretches down here. And then it goes up 1 unit for the translation up from k to right there. Another way of looking at this is that this would have been a maximum. So the reflection changes that maximum into a minimum. And your amplitude of 2.5 tells you that that minimum point right there will be 2.5 units below your midline. Then remember, 2 pi, because your period is 2 pi, so 2 pi radians later, you'll have another point of that type, which is a minimum. For cosine, halfway between two minimums is a maximum. And also for cosine, halfway between two maximums is a minimum. And then halfway between a maximum and a minimum is a midline point. And then you can draw in your curve and extend it. Here is a third practice problem that you can try. Pause your video. Let's take a look at this one now. All right, so period here is 2 pi divided by 1. Coefficient of x is 1, giving us 2 pi radians for the period. Amplitude is the absolute value of negative 7 halves, which would be positive 7 halves, which is also equal to 3.5. Midline would be y equals negative 2, your k being negative 2. So this one, the midline is drawn in for us, and we are graphing sine. So sine, remember, our unit circle tells us at 0 radians, the sine value is 0. So that means it's starting on its midline. So you'll notice 0, 0 moved down to the midline right there. 2 pi radians later, it's on its midline. Halfway between those two is a third midline. Then here's what's a little tricky about this one. Halfway between the first two midline points would normally be a relative maximum. But when a is negative, that means we have a reflection across the x-axis, so that maximum becomes a minimum, and its distance from the midline is 3.5 units, your amplitude. And then, so if this one is your minimum, then the next one will become your maximum. So halfway between those two midline points is your maximum, 3.5 units above your midline. And then you extend it to the left and the right. All right, I just wanted to finish up this lesson with this closure. A big idea for graphing sine and cosine is to make sure that you are thinking about your unit circle at 0 radians and what the sine value would be at 0 radians if you're graphing sine, and what the sine value or the cosine value at 0 radians would be when you're graphing cosine. So, because that's where it starts. So here I want you to think about, where does the sine function start? Does the sine function start at a maximum, a minimum? And by intercept here, we mean a midline point. And for cosine, does cosine start at a maximum, minimum, or an intercept, which also means a midline point? All right, so try these two closure statements. All right, let's see how you did. So when you're graphing sine, what you need to realize is the sine function, which at 0 radians, the sine value is 0, means it starts at an intercept, or what we call a midline point. But cosine at 0 radians is 1, which means cosine starts at a maximum. All right, that finishes this lesson. You may start your assignment and have a great day.